Hello guys, and once again welcome at my channel. You see I'm crashing the board today, so I'm uh, like in creative mood, and I would like to do one more video tonight. This video is going to be about the differential equations as well, like the first one, like the previous video I published like 15 minutes ago. And I would like to solve one more differential equation which is non-homogeneous. So we've been talking about homogeneous differential equations. That means I can bring the y part, let's have a look. I can bring the y part to the right hand side. So if I have y prime equals to y, I can bring it to the left hand side and I have 0 on the right hand side, so I don't have any kind of 5 or x or whatever value. But it's going to be different right now, so let us see if we have something like y prime equals to y plus x. So this is what we call the non-homogeneous differential equation of the first order, like there is only first prime. So how are we going to solve this one? Well, this is a very popular idea, not only in mathematics, but I think in the whole world. Like if you have a complex problem, you divide it into smaller pieces, you solve them separately, and then you put it together. So this is what we're going, divide and conquer, right? Dividi et imperi in Latin. So what we can do now, we are just solving the homogeneous equation firstly. So we solve the equation on the left hand side, we kind of forget about x. And what we're going to do then, once we solve the homogeneous, we're going to expand the solutional space. So you can imagine it like you solve an equation, which is easier, and then you can try to blow it further in order to get to the total solutional space. I hope the idea is clear. So we've solved the left-hand side already. We know that y in this case was k times e to the power of x. So what we're going to do now in order to expand the solutional space, we're going to treat k as a variable of x itself. So we have y star, which we call k of x times e to the power of x. So this is our model. We're trying to kind of squeeze the solution inside this equation, and what we're going to do now, we are going to find the derivative. So y star prime is going to be, so this is a product, we have to apply the product rule. So this is k prime of x times e to the power of x plus k of x times the derivative of e to the power of x. I hope you guys are familiar with the product rules. Otherwise, well, I hope I'm gonna make a video as well, but maybe not tonight already, it's enough. So I haven't been doing it for 4 years, and today I already third video, so I think it's fine. And I'll gonna try to make it once a week at least. So let's see. This is y star prime, which we can put this way. So that would be the left-hand side, and this is the right-hand side. So we would have k prime x times e to the power of x plus k of x times e to the power of x, which is going to be equal to y, which is k times e to the power of x plus x. So what we're doing now, we're subtracting on both hand sides k of x times e to the power of x, as you can see. So this is gone and this is gone. And what we have now is k prime of x times e to the power of x equals to x. So the idea of this one is just to solve it for k. We do it the same way we've done it previously. So we just, first of all, multiply times e to the power of minus x in order to solve it only for k. So we just have k prime, which can be written as dk divided over dx equals to x times e to the power of minus x. And what we're doing in the next step is the same stuff we've been doing previously. We're multiplying it times the x on both hand sides. We have just only dk equals to x times e to the power of minus x dx. And now we integrate again. So the left-hand side is just giving us k, which is absolutely fine, it's clear. But the right-hand side is a product, and we need to apply the integration by parts. Integration by parts, I just remind you, it's a kind of the inverse idea of the product rule for the derivatives. Like integration and derivatives are always interconnected. So the integral of, maybe you remember this, and most probably you've seen it as u and v in school, like it's everywhere around the world. I don't know why, actually. There are so many Latin and Greek letters. Why do we use so familiar? I don't know. That's the way it is. So let me just do it differently, okay? Let's break this rule. So we have p times t prime, and that would be p times t minus integral of p prime t. So the idea of the integration by parts is just to switch the order and to hope that the right integral is easier to handle than the left-hand side, right? So this is the idea. And we apply it here. Once again, I'm not proving it. Maybe I'm going to prove it. But this is, well, what we're doing now is actually a bit further already advanced, right? Like the basic idea of integration by parts is like 2 steps below. We're just a bit higher. So I assume that you're familiar. If not, let me know which videos you would like to see, and I'm going to change it. So the idea is just to actually to show everything that I know. This is maybe a very ambitious goal, but why not? What are we living for? All right. So just give it full steam ahead, and we'll see what's happening. All right. So let's see. I'll just take this one as t prime, if we look at the left hand side, and this one is p. So the original function of e to the power of minus x, this is the chain rule, this is minus e to the power of minus x. So minus x times e to the power of minus x, and then we have minus integral. P prime would be 1, and t is still minus e to the power of minus x. So we have minus here, minus e to the power of minus x dx. Is it getting easier? For sure, right? We have no x anymore. So minus x times e to the power of minus x minus e to the power of minus x plus unknown c. So that will be the k. I can take it out. I can take e to the power of minus x, maybe even with a minus. Well, let's do it. Minus e to the power of minus x, we're taking it out. We have x on the left hand from the first expression plus 1 plus c. And I'm claiming this is the value of k of x. So what would that mean? Well, that would mean that we've done actually. So what is our y star? Well, our y star now, as you can see, is equal to k, which is minus e to the power of minus x times x plus 1 plus c multiplied times e to the power of x. Once again, we use the distributive law. We multiply it out. So we multiply these two guys. They're canceling each other out. So we only have minus x minus 1. And then we have c times e to the power of x. I made no mistakes. Hope it's fine. How can we always check whether our solution of the differential equation is correct or not? Well, we have to check the equation. We want to solve this one. So y prime, what is y star prime now? That would be the left-hand side of the equation. Well, as you can see, this would be minus x minus 1 derivatives are minus 1 plus c times e to the power of x. That would be the left-hand side. But what would be y plus x? Well, y itself was this one, so minus x minus 1 plus c times e to the power of x, and we just have to add x, right? We just have to add x. This is the right-hand side we've chosen. So we have plus x and minus x, they are gone, and what we have is minus 1 plus c times e to the power of x, which is obviously the same result. So this was a non-homogeneous linear equation of the first order. I hope it was clear. And thanks for watching. I hope to see you guys in the next videos, and I also hope that it won't gonna take me 4 years in order to produce them. So thanks, and see you soon. Bye bye.